All right. So in the last couple of videos, we've been talking about different approaches to get at a causal effect of some specific treatment by making different kinds of assumptions, pretty strong assumptions about how treatment is assigned. Now, there's sort of another way to think about what we're doing in those cases, which is to go back to this idea of the counterfactual, which we haven't talked about quite that much in the last couple of videos, right? So remember from earlier videos, when we're talking about counterfactuals, what we're talking about is what would have happened to some treated group if they had not been treated, right? So going back to our idea of potential outcomes here, that's the counterfactual is, the counterfactual for the treated group is what's behind this door of the potential outcome that they would have had without the treatment, right? What's behind that door? We don't get to see behind that door because you can't see, two states of reality at the same time, right? So we're trying to come up with ways to guess at what's behind that door, right? And one way to think about the randomized controlled trial is it allows to get a really good guess at what's behind that door, right? Because we can guess that what that treated group would have looked like is the control group, right? Because the only reason they're treated and not controlled is because we just flipped a coin, right? Same sort of idea with the conditional random assignment. We're just looking at similar types of people or similar types of cities in the case of our example, and we're saying, this city would have looked like this city if not for the treatment, because they look the same on these other variables that we're conditioning on. Okay, so sometimes those approaches aren't going to be an option. They're not going to get us at a very good counterfactual, a good estimate of what the counterfactual for some treated group would have been, because maybe we know that there's something that we're not observing that could be important. Oftentimes, if we're talking about individuals, it could be something like ability isn't being observed. So, like, of course, some kid is gonna do better later on because we didn't observe their ability or their motivation, and maybe they chose to, go to some extracurricular study program because they were more motivated, right? And that motivation makes them more likely to receive the treatment. It also makes them more likely to succeed later on. Something like that. There's often cases where we're pretty sure we're missing part of the story of how treatment was assigned, and so we're pretty sure just controlling for some observed variables isn't going to get us there. So there's a couple other approaches. One that I'm just going to review a little bit because you guys have seen it, but just sort of refresh some of the intuition, is difference in differences. And to get at something like difference in differences empirical strategy, you need to have some panel data. So it's a little bit of a different setup to the data structure than what we've been talking about previously. And the important thing about panel data is that you have a couple different, you have multiple groups. In this case, I'm doing like the bare minimum here. You have multiple groups here. I've got Ramadi and Mosul, two cities. And you're observing those groups or individuals over time, right? That's the important piece that we didn't have in the previous examples, right? And so we can use that structure of the data with some assumption, with a couple of assumptions that we're gonna talk about, and we can use that to try to construct a counterfactual, right? To try to take a guess at, in this case, to try to take a guess at what Ramadi would have looked like in 2006 had it not received the treatment, right? So for our example, we're gonna say Ramadi gets the infrastructure program in 2006, right? And so they're treated in 2006. We want to get at what would have happened to them in 2006 if not for the treatment, and we're going to use the panel nature of this data along with our difference in differences assumption to try to build that counterfactual. Okay. Okay, so the big assumption when it comes to difference in differences, this strategy that you guys know, is that we're going to assume parallel trends, right? And what does it mean to assume parallel trends, right? What is that doing for us? Well, what it's doing for us is helping us build that counterfactual, right? Helping us sort of get a guess at what's behind that door, right? So in our sort of potential outcomes framework here, what we're after, another way of saying the counterfactual, right, is what would have the violence been in Ramadi if they didn't receive the treatment in 2006, right? I'm getting a little freewheeling with some of the notation here, but I think it's probably easier to do it this way, right? So if we've got parallel trends, if we're assuming that Ramadi and Mosul would have trended similarly if not for the infrastructure program in 2006, what does that mean for our counterfactual? Well, we're going to start with Ramadi in 2005, right? Without the treatment, right? That's observed, right? That's something that's observed because they didn't have the treatment in 2005, right? And then we're going to add on the trend, right? And because we're assuming this parallel trend, so we're assuming that what happened in Mosul between 2005 and 2006, Ramadi would have trended similarly if not for that treatment, right? So we're going to take the difference between Mosul in 2006 and and Mosul in 2005, and we're going to add that on to our Ramadi in 2005, right? So we're taking Ramadi and then we're adding on the trend from Mosul because we're making this assumption that they've got these common trends, parallel or also called common trends. Okay, so that's our counterfactual. That's how we build this counterfactual. And what is that going to look like, roughly speaking? It's going to look like, it's a little hard to do. So we're going to like tack this trend on for Mosul onto the Ramadi. And so we're going to come up with a counterfactual that looks like this. Here's our Y R 0 2006. My iPad's not working, so gotta do it old school here. Okay. So that's the basic idea for difference in differences. So we're building this is the assumption we're making to build the counterfactual. So what is our causal effect going to look like? Right? The causal effect is just going to be the difference between the counterfactual and what actually happened, right? So we're going to have what actually happened, which was Ramadi was treated in 2006, right? This is something we observe. This guy here is something we this guy here is something we observe, right? This guy here is something that we don't observe, right? We don't observe. That's our counterfactual, right? Obviously, we don't observe this second part, right? So that's where this assumption comes in. We're going to build this counterfactual, this sort of guess at the counterfactual based on that assumption, right? And that's going to give us something that we observe the whole thing, right? We're gonna take this guy and we're gonna subtract this thing out of it, right? So everything here we observe, and if our assumption is true, that's giving us the causal effect of this treatment. All right, so notice what happens here. If we work this through, we've got a difference minus another difference, right? There's our difference in differences. That's where it comes from, right? We've got the difference for Mosul between 2006 and 2005, and we're taking that out of the difference between Ramadi between 2006 and 2005. So basically what we're doing is we're taking the difference, we're taking the difference here, and that's our estimate of the causal effect of this program, right? The difference between what actually happened to the treated group and our estimate of the counterfactual. Okay, so how would we implement this difference in differences strategy in practice, right? Well, we'd add a couple more variables here, right? If you were looking at this data set and you wanted to run this, you'd add a couple more variables. So we'd add some variable for the post period, right? So we're gonna have a pre and post treatment and control. So after 2006 is our post period. So we create a dummy like that. We create a dummy. We've got our treated dummy, the group that's treated in this case. That's sort of a distinction from what we've done in the past, rather than like, are you treated in this specific year? And then we've got an interaction between, are you in the post period and are you in the treated group? Okay, so difference in differences, we're running a regression that looks something like this, where we've got indicator for the treatment, post, and an interaction term, treatment by post. Okay, so just to get a little bit of a better sense of what this is actually doing, let's break it down a little bit here. So let's start by thinking about the expected value for the treated group in the post period. What is this going to look like if we apply this conditional expectation to this guy here, right? Well, alpha is always alpha, right? That's just a constant, right? DI is 1, so we're going to get a beta 1. Post is also 1, so we're going to get a beta 2. And then since they're both 1, 1 times 1 is going to give us a 1 there. So we're going to get beta 1 plus beta 2 plus beta 3. Right? And then we've got this error term. So we're going to have whatever the average of that error term is for the treated cities in the post period. Right? And so we're thinking about this as sort of more than just these two cities. We're kind of abstracting away from that a little bit now, and kind of imagining that we have a bunch of cities, maybe in a bunch of years as well. Okay, so let's do this for the other cases as well, just to get a bit of a sense. So let's look at the treated in the pre-period, right? So if post equals 1, what's going to change in terms of what this expectation is going to give us? Well, this post is 0 now, and this post is 0, so we're going to lose this beta 2 and beta 3. Okay. Two other options. We've got the treated group in the post period. So what's changed there? We're losing this beta 1, but we are going to have that beta 2. No beta 3, right? Because we got a 1 times a 0 still there. We still got this extra residual that we're gonna have to worry about at the end. And then the non-treated group in the pre-period, All these other guys are zeros. So we're going to have something that looks like that. Okay, so what is our counterfactual that we're after here? Well, we're after the counterfactual for this guy, right? If we're talking about difference in difference, right? If we're trying to build our difference in difference estimate, right? What is that going to be? That's going to be what actually happened to the treated group minus the counterfactual, which was, if you remember from a second ago, we're just doing it in kind of fancier mathematical language now. We're subtracting away what happened in the treated group on average in the pre-period minus that trend, right? The difference between what happened to the control group in the post-period minus what happened to the control group in the pre-period, right? So that's our difference in difference. Our difference in difference estimate. Let's do it like this, yeah. Okay, so that's our difference in difference estimate. How does that relate to our regression? Well, let's plug all this stuff in and see what happens, right? We've got this guy here. Let's do it in lines so we can sort of keep track of it a little bit better. Minus this guy here that we've plugged in, minus this guy, minus this guy, and they're in parentheses there. Okay, so right off the bat, we can kill a bunch of stuff. I'm gonna paste it down here so we can follow along here, right? So let's say we got an alpha here, and we've got a minus alpha here. Sorry, this should be in parentheses because we're subtracting that whole term, right? So we can kill that alpha, kill that alpha, kill this alpha, and this alpha. We got a beta here and a minus beta here. We've got a beta 2 here and a minus beta 2 down here. So we can kill those. And what do we got? So we've got this beta 3 is our difference in difference estimate. Beta 3 plus all this nonsense, right? So think about what that nonsense is. That's about the residuals, right? That's a difference in difference in those residuals. So long story short, if we're correct in making this assumption that we've got parallel trends, then this whole thing is going to go to 0, right? That whole thing's going to get knocked out, right? And so we've got our difference in difference estimate, right? That assumption about parallel trends to build that counterfactual. That means that this beta 3, this coefficient here, that's our estimate of the causal effect given that assumption to build the counterfactual.